Alrighty, here we go. We are going to take a little pause and review what we did last week because solving systems is kind of tricky. Keeping in mind that you are always trying to get an XY coordinate pair that makes both equations true. That will be called a solution. So your solutions are going to look like coordinate pairs. We learned a few different ways. So we're going to be practicing graphing, substitution, elimination, and elimination when you have to use multiplication. I do want you to check your answers. There's only 5 problems on today's notes, and it's a good tool to learn how to check those answers and see if they're right before you would enter them into Schoology or just before you would move on in general. Your weekly homework is going to look different than normal because it's just going to be more worksheets like this one. So every day will look the same. It'll have the same types of problems, same number of problems. And so today your actual homework is just to pay attention to this video, fill in your copy of this notes so that you have it to look back at. And then the rest of the week, you'll just be practicing a sheet just like this. And then the last one you do will be graded as a quiz. So here we go. When you are trying to solve by graphing, the goal is to graph both. And they're both going to be lines. So we're going to graph both lines. And then we're really just going to see where they cross. And they're going to cross at a point. And so that point will be our solution. Now, to graph both lines, we're going to get it into y equals mx plus b form. I think that's easier for most people. Now, sometimes it is. This top one already is. Keeping in mind that when we have mx plus b, the last value, which is the b value, the -4, tells you where it's going to cross the y-axis. That's our y-intercept. And then this number is my slope. So I'll be going up 3 over 1, up 3 over 1, up 3 over 1, and so on. And that is going to be my first line. Make sure you connect your dots. Just having a series of dots is not a line. So that's line 1. Now I have to go back and I have to draw line 2. And line 2, you can see, is not in slope-intercept form yet. It has a y minus 3. I want the y alone. So I'm going to add 3 over to this side. So y equals -1/2 x plus 3, because they don't go together since one has an x and one doesn't. They are not alike. That's the line that I'm going to be drawing. Let's draw that one in red. So again, this number tells me where to start on the y-axis, and this number tells me how to move. So from that point, I go down 1, over 2, down 1, over 2, and so on. Then I'm going to connect my dots the best that I can, use Notability to help me get a good straight line. And now I'm looking for the point that they share or have in common, which is right here. That's over 2, so an x of 2, and up 2 as well. So it looks like my solution is going to be 2, 2. But I want to check. So I go back to my original problems, and I plug in a 2 for x in this case and a 2 for y. So my first equation would read 2 equals 3 times 2 minus 4. So that would be 2 equals 6 minus 4, which is certainly 2 equals 2. Now I need to check it in the bottom equation. I'm putting a 2 in for y and a 2 in for x. On this side, 2 minus 3 is -1. And over here, -1/2 times 2 is also -1. So that answer checks and is my solution. Awesome. Our next method of learning how to solve these was substitution. So what we did there is we looked at what we had, and we would say, like in this top equation, y is the same as -3x plus 5. So where there's a y in this other equation, I can substitute in what it was equal to, -3x plus 5. So I'm taking this whole thing, substituting it in for the y. Now I have one equation with one variable that I can go ahead and solve like we did back at the beginning of the year. So my -4 distributes, the negatives cancel here, but not here. These are on the same side, so I put these together. I add my 20 to both sides. When I divide by 17, you can see that I get an x value equal to 1 So it seems that the x coordinate of my solution will be 1. Now I can go back to either equation and plug that in to find y. The top equation will be easier because it says y will equal -3 times whatever you got for x plus 5. So that's -3 plus 5. So in the end, y is 2. So I think this is my solution, but part of what we're practicing is checking that. So I go back to my original problems. I put a 2 in for y. I'm working on the first problem. And I put a 1 in for x. So then 2 equals -3 plus 5. So 2 equals 2, and it checks in the first equation. How about in the second? It's going to be 5 times whatever you had for x minus 4 times whatever you got for y, and it's supposed to equal -3. So 4 minus 8 does indeed become -3. So the second one checks, and I am confident that this answer is correct. That's my solution. What about elimination? Well, substituted, elimination eliminates. So I need to add or subtract the equations together, looking for an equal but opposite pair. -6x and +6x eliminate. A 5y plus 4y makes 9y, and a 1 and a -10 makes -9. Dividing by 9, I get the y part first, and that equals a -1. So I put it into the y place of my solution set. But now I need to go back to one of these equations. It doesn't matter which one. And I need to put in for y the number that I just got in order to find x. So I'm using the top equation, putting in my y as the y value. So -6x minus 5 equals 1. And then I'm just doing the algebra we learned earlier in the year. Dividing out my -6. I find out that x is -1 as well. Okay, so I think that's weird because my, answers are the same, but it doesn't mean it's wrong. But like always, it's a good idea for me to check. So I'm going to take the top equation, -6, then I'm plugging in the x value I got of -1, plus 5, then I plug in the y value that I got, also -1, and I'm checking to see if it equals 1. These become a +6. This becomes a -5, so 6 and a -5 does indeed make 1. So my solutions work in this top equation. Let me check the bottom one. When I put a -1 in for x, and again for y, will I get -10? -6 here, -4 there. Does that equal -10? Sure does. So that means it checked in the second equation, and -1 is definitely my solution. Which is why you could, before you turn your paper in, you should already know if you got them right or wrong. We're still doing elimination, but now that equal but opposite pair doesn't exist already, so we're going to be using multiplication to help create that pair. When I look at this first one, I see a couple of different things that I could do. Probably the first thing that I see that looks pretty easy is to turn these both into a positive or -6x. And I can accomplish that. They're already, one's positive, one's negative. They're already opposites, but I could multiply the entire bottom by 6. So I'm leaving the top the same. And here I'm going to multiply every single thing by that -6. Okay, now I have that equal but opposite pair, which will eliminate when I go to put them together. Wow, this is going to be -48y. This turns into 0. So when I divide by -48, 0 divided by anything stays 0. So a lot of people get nervous when they get 0, but 0 is a legitimate answer. So I'm just going to go ahead and put that in as my y and see what I get for an x. If I did something wrong, I'll be able to tell later when I go to check my answer. Let's go ahead and solve for x. I can take either equation, so I'll just use the top. I just need to put in for, that got kind of messy, sorry. I need to put in for this y, the y value that I got, which happens to be 0. So negative 12 times 0 becomes 0. When I divide by 6, I get an x value of 4. So this is my solution set right here. My coordinates are 4, 0. I'm not confident because I feel like, wow, is 0 going to be weird? Let me check. So when I go to check my answers, take my top equation. Where there was an x, I will put in a 4. Where there was a y, I will put in a 0. That'll turn into 24 minus 0 equals 24. So it checks in that top equation. How about the bottom equation? I have a negative, then I plug in my x, a minus 6, then I plug in my y, and it should equal negative 4. So this becomes negative 4. 6 times 0 is 0. So negative 4 equals negative 4. That checks as well. So now I'm more confident that 4, 0 is my solution. Last one is still the same process, but here in order to get a matching pair, I'm going to have to multiply both the top and the bottom by something. And you can either multiply 5 and 3 by something to become the same number, or 4 and 9. It's totally up to you and kind of whatever you see first. I'm going to go ahead and I'm going to match up my x's. And I'm thinking, okay, I can turn 5 and 3 both into 15s by multiplication. I need them to be opposite. So the top I'll multiply by a positive 3, which will create a 15. But then on the bottom, I'm going to multiply by a negative 5, which would create a negative 15. So let's go ahead and multiply the entire top by that 3. So 15x. This will become a plus 12y, and this is going to become negative 90. On the bottom, I'm going to have negative 5 times 3, so I'm getting that negative 15x that I needed. Here the negatives cancel, and that turns into positive 45y. And then your numbers are getting kind of big in this one, so obviously you can use a calculator. Negative times negative turns into positive 90. All right. Now I have that equal but opposite pair. I have a positive 15x and a negative 15x, so those cancel. This becomes 57y, and this becomes 0 again, which is totally fine. I divide by 57, and I get 0. So just like getting a 1 or a 2, don't panic when you get a 0. It's a legitimate number answer. However, now I have to find my x. So I'm going to go back to one of the original problems. I don't really care which one, so let's just grab the top one. This was my y coordinate. So when I go back, I'm going to put that number 0 in where there was a y. And that'll help me solve for x. 4 times nothing is nothing. So I have 5x equals negative 30. Dividing by 5, I get an x value of negative 6. And now all I have to do to be done for the day is check that when I put those numbers in for x and y, I'm going to be able to make both of these problems true. So top equation, putting in a negative 6 for my x, a 0 for my y, checking to see if that will come out to be negative 30. This is negative 30. This is nothing, so that does work. How about the bottom? Putting in a negative 6 for x and a 0 for y, will I get negative 18? This is negative 18. This is 0, so that one checks as well. So when I'm done, I have an XY coordinate pair. I can check them, see if they're right. We're practicing doing all the different methods. So throughout this whole week, if you're getting stuck on this kind of problem, come back and watch this part of the video. If substitution's giving you trouble, watch this part of the video. If you're struggling with the graphing, rewatch the beginning. And then you can practice each day. You're going to do a worksheet that looks exactly like this. And then on Thursday, you'll have one that is a quiz that looks exactly like this as well. So have a great week, guys. Bye.